We had a lot of questions, or we commonly come across this theme when companies are competing with the leading public clouds. Sometimes because they're providing a public cloud service or a hosting service, managed service offering on the market, or sometimes because they have a private cloud and they're considering moving to a public cloud. So they want to measure how their service compares to the one of the leading public clouds. And when you consider cloud, you can focus on several different ways of assessing this technology or that offering. And here we put on the first place the technology that they're using, simply because it has a lot of implications or defines a lot about the offering of the cloud. In this case, it would be the security, data reliability, performance of the service. Sometimes it has to do with service levels that they can cover. And last but not least is the price. I think we'll put price at the end of the list because it's important, but in our experience, price alone doesn't tell whether you're going to get a good service. Usually, the lower the price, the lower the quality of the service. So we always advise companies to consider on a more complex metric like price, performance, or value for money. Another thing is obviously infrastructure for any public cloud is the thing that makes or breaks the business. So we've seen a lot of companies are moving in and out of certain providers or from their own homegrown technology because they have different kinds of problems. Sometimes it's performance, sometimes scalability, sometimes it's reliability of the service, meaning downtime, the lack of high availability and things like that. Sometimes it's poor support, a lot of time and effort that sinks into support or troubleshooting issues. And that's time not spent on building the business and growing your business. So that has a hidden cost. Sometimes the companies you work with have clumsy and slow business process, meaning they're not agile, very slow response times and things like that. And again, last but not least, high service cost, and which is making the service less competitive. And again, in many cases, this is hidden through poor performance or poor service that you're getting, not necessarily high price of the solution. So to adjust for that or to measure the current state of the cloud services on the market, we've done a performance measurement of several leading clouds. In this case, we've chosen Amazon AWS, DigitalOcean, DreamHost, and OVH. And then we've measured them to a number of StorPool powered public cloud offerings. And we focused on storage performance for this measurement, which is paramount for the level of snappiness or performance that you would get on all the applications that are running on top of this cloud, simply because most applications have a database somewhere inside, and this database is usually storage bound. So if you have a heavily loaded website, if you have a database running, if you have a WordPress site, if you have an online store, a SaaS application, all of these applications would require a very fast storage service, which in most cases is the thing that's slowing down the entire site or the entire application, since storage is the most or the slowest component. So here we're focusing on storage-related performance, and we did our best to adjust or to have a common denominator between all clouds, because you cannot get exactly the same resources from all of the clouds that we've listed here. So we did our best to have common platform with the same VM instance size, the same settings, etc. So the performance tests we conducted were related to the performance of the storage system, as I said, and they were 4 types of tests. One is pgbench, which is the standard PostgreSQL database benchmark, perhaps the closest to application performance, raw application performance. We done the typical sysbench MySQL benchmark, which is also kind of showing whether pgbench is off or is it close, are the two most common database applications on par. FIO is a very standard or the most widely used storage performance testing tool, and rsync, a simple command to copy files and sync, which is basically simulating test dev deployments for different test dev environments and backups. So here we have the parameters of the virtual machines that we've compared. And you can see on top is the StorPool BCP, which stands for Best Current Practice, which is an NVMe powered system of a customer that's doing shared hosting, heavily loaded shared hosting. So all of the systems have 16 gigs of RAM, except OVH, which had a bit more RAM, 30 gigs. All systems had 8 vCPU cores. And in this case, we basically also plotted the price of this virtual machine from the different providers. As you can see, it varies a lot. And again, as we'll come back to this later in the slides, just trying to judge the quality of service from only the price is very misleading, and we'll show why. So here are the storage volumes that we're looking at. We mentioned that we're doing a storage-centric evaluation here because storage is at the heart of the application performance. And in this case, we were looking at external storage, meaning shared storage functionality with each of the vendors that we're assessing. And we try to do volumes that are more or less consistent, which are about 200 to 300 gigabytes. With some vendors, unfortunately, that was not possible. So we've kind of selected something that should have enough performance. We're looking at services that have unlimited or very high IOPS limit. So we can basically measure the actual throughput of the entire system and the latency of the system. As you can see, again, the monthly cost for this, only the storage service, varies tremendously, and Amazon is by far the most expensive service from the ones we compared. So here is the first test we did, which is the pgbench for database. In this case, we're using a data set that's 4 times RAM. So it's much larger than what the virtual machine can cache. In other words, if you're reading any performance test that relate to storage, look if the vendors are showing you something that's coming out of RAM, which is a common trickery that some vendors use. Your data set should be much larger than RAM, so you actually hit the actual storage system. In this case, we're measuring transactions per second of the database versus the latency that the database delivers. And here we have the results plotted. We can see AWS in orange, which is by far the best from DigitalOcean, OVH, and DreamHost. And you can see the StorPool powered clouds are on par or above and beyond this system. And again, as we looked earlier, the Amazon service is $333 per month, this specific volume with a lot of IOPS. So it's 3 to 10 times more expensive than anything else on the market. So this graph shows us basically that, for example, if you're looking at a heavily loaded application, if you're looking at the top, which is the heavily loaded NVMe powered cluster delivered by StorPool, it can peak at about 9,000 transactions per second and still keep the latency at about 4 milliseconds, which is okay for a system that does so many transactions per second. And if you have a website, that needs to open a home page, it easily sends hundreds of requests to the database underneath to serve different types of pictures, code, etc., etc. So here we've zoomed in on the above test to basically show the latency for the part of the curve that matters. As I said, the heavily loaded website would generate hundreds of IOs, and we're looking at what would be the snappiness, the response of the storage system in terms of transactions processed for very low latency. I think we did another webinar about why latency is the #1 metric of any cloud, be it public or private. If you haven't seen that, you can find, you can just search it on our website. But basically, latency is the #1 metric for any cloud, any application. And in this case, you can see that a powerful storage system translates to a very, very fast application that's running on top, meaning a latency that's in the region of half millisecond to 1-2 milliseconds. And here we've shown that a lot of the guys are talking about DigitalOcean and OVH's Dreamhost, but these services that are doing 20 milliseconds of latency are not particularly fit for running databases and applications. Anything that does arbitrary something above 5 milliseconds, 10 milliseconds, is just dismal performance because you have the multiplier factor on top. If you have a lot of IOs or a lot of transactions that are requested by the database and cannot be serviced by the storage system, this just piles up. And here we see an example of how this just adds more and more latency with every request that you shoot to the system, and your website becomes irresponsive and an application is lagging tremendously. We've done the PG bench. Here we've done a small test with RAM that's a data set that's comparable to RAM, but again, pushing it to the storage system, and we measure performance, which in this case, as you can see, caching in RAM improves the performance of the storage system, which is natural. However, sometimes you have databases that are very large and you cannot fit in RAM, and in any case, you're looking at improving all the layers in your IT stack to the maximum extent possible, and most websites are already cached and have caching plugins, so in many cases you're again hitting the storage system. Here is, I think, a more interesting test about latency of the storage system, and as we can see, a typical cloud service provider that's considered very inexpensive and very good is DigitalOcean, which has latency that's in the group that we measured, the second worst latency in this case. AWS, which performs quite well, and as I said, arbitrary, anything above 1 millisecond, 2 milliseconds is quite bad for a storage system, and then for the application on top because of the pile-up effect. And here we're, obviously the read latency is lower than the write latency, which is typical. In some providers, they are more or less consistent or have small difference. In some vendors, they vary a lot, which talks maybe about some caching technologies that are not very efficient that are used in the given provider that we tested. On the flip side, when you measure latency, one metric is how fast the system responds. IOPS gives you how much this system can actually perform in terms of storage operations that are feeding the database on top. And in this case, we're seeing that with the StorPool technology, for example, we can push more than 100,000 IOPS per single VM. With different providers, I think these are different generations of hardware. So in this case, I think eApps, for example, is way faster than AWS. We'll come back to this later. They're using an SSD hybrid system, which if maybe these tests were actually run towards the end of last year and early this year. So I assume new hardware upgrades will have them performing like the cluster that's NVMe powered, which is way above anything else on the market in terms of AWS DigitalOcean or Azure.
Boyan, sorry for interrupting you just for a second. We have one question on the chat, which is in regards to the performance achieved with StorPool. So the question is, what is the maximum IOPS which can be actually achieved with StorPool storage?
This depends on the size of the system and obviously of the hardware that's used, and also depends on the workload that you have running, so how busy the system is. For example, in the beginning of the year, we did a test with Intel on 13, I think 12 or 13 NVMe powered servers, and we reached a 13.8 million IOPS, which is by far the highest result that they've seen on their setup, which is actually surpassing Microsoft result. Although it was coming from RAM, was not really hitting the storage system, but StorPool was faster. So if you have an NVMe powered system, that's going to be much faster, obviously, than a SATA SSD powered system. If you have more servers, you can have a faster system. If it's not very loaded, it's also going to be fast. But in any case, you can easily get above 1 million IOPS easily, and above 100 or 200,000 IOPS per single VM.
Yeah, maybe it's just a comment which is here on the chat that not all of the hosters can invest in NVMe's only. So maybe, Bon, you can give some kind of recommendations how hosting and cloud providers can actually achieve a good performance, not only with NVMe's. Like, I mean, is everything depending only on the disks, or it depends also on different factors?
I think, yeah, it depends on different hardware. So if you have CPU cores, which are with high frequency, less cores with higher gigahertz frequency, that is going to accelerate any application running on them, or most applications, because most applications are not very well multi-threaded. But NVMe, I think there is a misconception. I think if you're running an NVMe-based system, because the NVMe systems are much denser than even standard SATA SSD systems, they're maybe 5% more expensive. I think we did a design for an entire cloud for a customer in Argentina earlier today, and the difference between an NVMe powered system and a SATA powered system was about 5-6%. So it would be much less. It's surprisingly not as expensive as most people think. Otherwise, you can achieve the same thing with SATA SSDs. Like if we look at, I think the second one that we have here against StorPool powered cluster with Togglebox, this is SATA SSDs. So it's, good performance is achievable with inexpensive SSD nowadays, something in the region of 30 to 50 cents per gigabyte for the SSD.
Thank you, Bon. That's really sounds logical. So one more question from the chat, and we are going back to the presentation. So Bill Reed is asking what decided which providers you're testing, and that he's surprising not to see Azure, Google, and perhaps IBM. Maybe I can give a short answer to the question, and Boyan can help me. The reason for testing exactly these cloud providers is that StorPool is primarily focused on providing storage system for public cloud providers and hosters. That's why we decided to test the leading players in the cloud and hosting domain. And maybe, Bon, you can share a little bit more on this question.
Sure. So, as any test, you can limit or you can focus on testing some specific systems. We've tested, in this case, AWS and DigitalOcean are the two most common competitors that we see to some of our customers and all the other clouds we're talking to, be it public or private. I think AWS alone has more market share than Google, Tencent, Alibaba, and Azure combined. So AWS was a natural one. DigitalOcean is very popular for inexpensive and fast services, although it's usually not highly available. OVH is an interesting player which is extremely aggressive on price and has a global spread, although it's stronger in European market. And you have DreamHost is the leading example of running a safe deployment, which is another tool that we see a lot. In many cases, people think that solution is very good and it has its strengths, but as we can see, storage performance is not one of them. So this is how we came up with this 4 companies that we tested. And maybe we'll include GCP and Azure in coming update this performance testing exercise.
Thank you, Bon. Yeah, that's really just initial performance measurement, which we have done earlier at StorPool. At any case, we will continue provide such statistics and information because it's really valuable to the market and can give you an idea how to benchmark your own service. And maybe we can go back to the presentation and continue with the questions a little bit later.
Sure. One last note on this, we were also publishing the benchmark testing suite that we're using for this, and anybody can test their own cloud or selected cloud. You can use this framework and just check out a VM in a given provider and test it with the same tools to get the comparable results. Here, again, we're measuring the next test is FIO, which is throughput of the system, sequential read-write block size 128, and we have QDET, which is the number of parallel requests to the system, because in a loaded cloud, you usually have many workloads that are trying to get access to the system. And here we can see that for a single VM, I think the lowest number is something like, what is that? About 100 megabytes per second sequential write. The best one is about 1500 megabytes per second. And basically you can see a lot of these. We have it in a more detailed form on the link that we'll send with the slides. So I think, yeah, we're getting to the tools that we provide or use to measure performance. And we've done a storage performance and resilient testing guide, which is a white paper that we've done for testing storage systems. So in this case, we've included the PGBench testing, SysBench, rsync test, and a number of other useful tools if you're interested in testing storage systems in particular. And we have also a link to that guide. So we have something about price versus performance and total cost. Obviously, this is becoming a bit complex topic with when you want to calculate what is the price or what is the total cost of ownership of a given cloud service, because you need to factor a lot of things like hardware cost, software cost, data center expenses, etc. To help that, we've done
Well, just one question, once again, sorry for interrupting, but I think that our guest speaker, Richard, can also help us on this topic. Richard, do you think that the hosting companies have a common, and the cloud providers, of course, they have a common understanding how they can make a calculation of the total cost of ownership? Because usually we see people who are counting the price per individual component of the storage system or the cloud system, and most of the companies maybe are calculating the TCO in different ways. So maybe you can share from your experience how you are doing it.
Sure. I don't have my calculations and all in front of me, so I'm kind of speaking from a logical point of view. But we look at, of course, the cost of any hardware we have to buy, any software, the licenses that's associated with that, and we also take into account how much labor and effort it's going to take to support that that infrastructure. In addition, we have to take into account the space that the hardware occupies in the racks, and as well as any power. And then you have to factor in some kind of a useful life. How long do you expect this to to be useful? One of the most complicated things about figuring out a total cost of ownership is figuring out how do you add capacity and how to calculate the impact of adding capacity. And what I mean by that is, if you have yourself a system that if you need 10% more capacity, but because of the design of the infrastructure, you have to add 50% more capacity, and then you have a lot of idle capacity that you have to fill over time, then that really impacts your TCO calculation, because you're just wasting money on something that's not going to be used until many months or time down the road, and you can't scale it back down. So I'm sure every accountant, every company would take a look at this a little bit differently, but those are the major factors that we try to take into account.
It really sounds logical that you always need to think about the scalability and how you can actually expand your system and how much will it cost actually for you. So Bojan, going back to you.
Yeah, I skipped a bit of slides, but I'll come back to these very quickly. So in the old days, you had this concept of how you build a cloud, and it was 2 or 3 letter vendor for the server bit. You were using VMware, Zen, etc. Cisco gear for the networking. Then you were using fiber channel to connect to a SAN. In the less expensive version of that, you were using local storage, but then you didn't have scalability, high availability, redundancy, like a proper storage system, a proper cloud. In the new age, you do something that's white box servers, white box switches, and one of the usually KVM-based alternatives, and then you use a software-defined storage solution running on the same servers. And except maybe scalability and complexity, the old approach was still good, except it had very low return on investment or very high TCO. This is one of, or these are a couple of drivers, which is complexity, reducing vendor lock-in, and much lower cost, which were giving this new notion or this trend of adopting software-defined technology that are faster, better, and cheaper, giving much higher return on investment. So here we've done a small analysis trying to see what would be the differences in terms of price per virtual machine with specific parameters. In this case, 2 gigs of RAM, 2 TPU cores, and 40 gigabytes of SSD storage. And we've done a full-blown ROI calculation with it's a large Excel that shows what is the data center cost, and you can use it and tweak it to calculate your return on investment or your total cost of ownership. So it has assumptions that you can tweak, such as price of power in your data center, the density you can get in terms of kilowatts, etc. The only thing it doesn't include is staff and marketing costs, because these vary greatly between one company to the other. So, and obviously you know your business best, so we've left this out, whereas infrastructure is rather standard all across the globe, so doesn't vary that much. So yeah, the return on investment, as you can see, is quite different. We have here a small screenshot of the file, which you have input fields, and you can tweak to your cloud, and behind it there is a much more detailed calculation, and we can help you understanding that or tailoring it to a cloud. And again, there is a link to that where when we share the slides, you'll get access to that as well. So I guess this is. Mm-hmm.
Yeah, thank you for the presentation. Actually, it's always good to see how the leading companies are performing in terms of performance. But at the end, hosting companies need actually to translate the performance and all these metrics to a language which is understandable by their customers and to get the maximum benefit out of it. So we wanted to invite a guest speaker to our webinar, and we have chosen Richard from eApps, because we really believe that they are a company which has a good marketing approach, and they can give a practical example to other companies how performance actually matters when they are in the battle for more customers and bigger market share. And we really think that the opinion of Richard will be valuable as a practical example of how to achieve bigger market share by using performance as a key metric inside your cloud. Richard?
Thank you, Yvette. As I mentioned before, we've been a customer of StorPool for almost 3 years now. I'll give you a little bit of background on us and why that's important in this context, but we provide managed hosting services, and many of our customers have mission-critical apps that are very dependent on performance and high availability, and we have some very sophisticated services that are critical. Performance of your storage system is really, really important. It's a foundation element of your infrastructure. We struggled with some other approaches in the past, and fortunately we found StorPool, and that's been very, very successful for us. If you can go to the next slide there, Eva. I think I just covered that also. Mm-hmm. So we went with StorPool from a traditional SAN. This was a redundant SAN that was synchronized, and we had a lot of problems. It was mechanical disks. We had issues with upgrades, reliabilities. Anytime we had to do any type of a serious upgrade, we actually had to take the whole thing down in many cases. And it was really important for us, for the success of our company, to find a solution that was fast, reliable, and had zero downtime maintenance, and also easy expansion. We had a situation in the past where if we wanted to increase our capacity, we had to make a very big capital investment. So some of the things that we've benefited from and have been a key to our success here using StorPool. With some of these applications that we have, latency is really, really critical. Some of our customers, we have them spanned across two different data centers, and their databases are synchronized in a synchronous mode. So data must be committed to the other database before the transaction can complete, and this is going across a geographical distance. So you have built-in latency to go across the internet, but the performance also of the application and the database transaction performance itself is absolutely critical. We've actually had at least one customer, we tried to span them across two different data centers, and we couldn't do it because their application was so poorly written that the database transaction processing was just too slow. But for any customer that has had you know, a well-written application and a well-tuned and database, we've been successful in spanning them across two different data centers, and we simply could not have done this without a high-performing storage system. Again, adding capacity has been very good positive experience for us and our accountant. We can simply add another storage server to the cluster, and there's no blip. It's just smooth. We don't even know what's happening. The last thing is we also rely quite a bit on StorPool's proactive support function. We have actually cut down on the amount of staffing that we've devoted to our storage system since we switched to StorPool. In terms of reliability, it's been outstanding. The facts of it are we've been on 3 clusters that we have, 3 StorPool clusters in 3 years. We had 1 short outage of less than 30 minutes total. And we were actually surprised that we had that. It's just so reliable. It just always runs. So it's been extremely reliable for us. We have a mix of SSD and mechanical disks, and it performs, our guys believe it performs about as well as a completely SSD configuration. So that's saves cost on the equipment. Overall, our total cost of ownership is much less than with our old approach.
That really sounds impressive that you're able in the same time to decrease the total cost of ownership and actually to achieve better performance. So one question from the chat is, do you recommend thinking for OPEX or CAPEX? I'm not pretty sure if that's only for the storage system or for the hardware entirely, but I think that our speakers can give some answers on this question.
From my point of view, you have some things that are always capex or usually capex, and other things that are really usually opex. I think the very typical for the service provider industry that is called hosting telcos is that you take as much as possible on opex these days. As you know, I'm talking at least to some companies. They say if I can lease my desk for $2 an hour, £2 an hour, €2 a day, I'll just lease my desks and my chairs and everything. So that's where I think the global economy is heading towards more and more OPEX. However, if you're buying equipment, that's usually CAPEX unless you can lease it again and switch it to OPEX. Yes, it is more expensive in the long run. If you're doing 5-year TCO, OPEX is more expensive. Yet it is making your business model possible because it doesn't require millions of investments upfront as in the CAPEX world. So that would be my take. Maybe Richard has something to share as well.
Well, fortunately, we have an accountant that figures a lot of this out, but we maybe are not as sophisticated as the way some people look at this. But we gather all of our relevant costs, and we take a CAPEX view of it, and estimate the useful life, and calculate a per unit cost based on that calculation over a multi-year period. And we just strive to get that number as small as possible, and then we factor in the how easy we can add capacity and what that's going to cost us.
Yep. Richard, what would be the typical amortization and depreciation period you use? Is it more like 3 years? Is it 5 years? Is it something else?
Typically, it'd be 3 years.
Okay.
One more question from the chat again. Who is the typical buyer? Bill, maybe you can specify whether you're talking for StorPool as a storage solution or for high performance hosting cloud. But if we need to, okay, for StorPool, Bon, maybe you can answer.
Yeah, I didn't really got the question.
The question is, who is the typical buyer for StorPool as a storage service?
Oh, broadly speaking, these are all public or private cloud builders. Typically, these are companies that build clouds. They want to have a highly available and fast, reliable storage service, which basically allows their workloads, be it their own workloads, as in case of financial or SaaS companies, or their customers' VMs, in case of public clouds, managed service providers like eApps, for example, to have high availability, very good uptime, very good performance. So the typical customer would be, for example, a service provider that is thinking of going to an all-flash SAN vendor. And as we've seen, it's a good solution, but it's not very economical these days. Or sometimes it's private clouds like banks or other software as a service companies that are managing their own private clouds. So this would be the two groups of typical customers. And inside of that, you have, obviously several different segments. Like we track different companies that are doing, for example, shared hosting, infrastructure as a service, managed service providers, telcos, financial, etc. But typically, everybody who needs a fast and reliable cloud, be it public or private.
We know that actually the hosting market is changing a lot in the recent years. There are a lot of acquisitions and customers are very price sensitive. So as we're at the end of our discussion, I was wondering, when we talk for performance, do the end customers actually care for performance and appreciate what is the value of having a high quality cloud with exceptional performance, or they only care for the price of the service? Rick, can you share some insights from the market in the United States?
Yeah, that's a good question. It really depends on the customer and the type of application. Many of them, of course, they can tell if the site is really slow, but they can't tell that it's really fast. But those customers that really have heavy workloads or have more sophisticated workloads, they're looking at all aspects, and often they're using tools that can assess bottlenecks and see exactly where their performance issues lie. And these more sophisticated customers are very, very aware and knowledgeable about the speed of the storage system.
Thank you for the answer. We're at the end of the webinar, so if there aren't any other questions, I just want to say, everybody, thank you for being with us tonight. And actually, in the United States, I think it's about lunchtime. And Bojan and Rick, thank you also for the detailed explanations and wonderful presentation.
Thank you too.
You're welcome. My pleasure.
Have a nice day, everyone.